Hello, hello. Welcome to our day of review with functions. Go ahead first and complete your warm-up. As a hint for number 1, it'll be important to create an equation. Okay, so for number 1, saying Jada is 6 years younger than triple Ariana's age. So younger, that tells me I'm going to need to subtract. Triple means I'm going to need to multiply by 3. The sum, okay, sum means I'm going to be adding sum of their ages. So I have to add their ages. So this is one of those ones that we can, and it's a good idea, to create a little chart so that we can identify how to represent each person's age so we don't forget anything. So Jada is 6 years younger. So that means I'm going to have to be subtracting 6 from something. Again, if you're 6 years younger than your brother, you're not starting off with 6. You're taking away 6. 6 years younger than triple Ariana's age. I don't know Ariana, so that means I'm going to have to do triple 3 times x. So that means Ariana, since I don't know her age, is going to be x. So that right there is the most important piece to remember, that I have that other x there, because it says the sum. So I need to add Jada and Ariana's age. So it's 3x minus 6. That's not equal to 62. It's the sum. So I need to also add Ariana's age, which I don't know, and that all equals 62. So don't make the common mistake of just setting 3x minus 6 equal to 2 or 62, because it's the sum of their ages. From there, on the left side, we reviewed this yesterday. I can combine like terms. 3x plus x gives me 4x minus 6 equals 62. Do the opposite, so I'm going to add 6, to both sides. I get 4x equals 68. Divide both sides by 4. And I get x equals 17. Always go back to the question. It says, how old is Ariana? Ariana was represented as just x, so I am done with 17. 17 years old is how old Ariana is. Okay, number 2, what is the value of x? So here I see that I have a triangle and I have an exterior angle of a triangle. It is on the outside of the triangle. It is touching one of the sides. So that means the exterior angle is equal to the sum. We reviewed this the other day. The sum of the two non-adjacent, so the two opposite angles of the exterior angle. So that means 75 plus 6x plus 11 all equals my exterior angle of 19x plus 8. Again, exterior angle of a triangle equal to the sum of the two non-adjacent angles. So I can combine like terms to make my left side shorter. I have two constants I can combine, no x's to combine, so that's 6x plus 75 plus 11 is 86. Equals to 19x plus 8. I'm going to get rid of the smaller coefficient, so this left side, I'm going to get rid of the 6x, subtract it from both sides. That cancels out, and I'm left with 86 equals 19 minus 6 is 13x plus 8. Subtract 8 to get x by itself on both sides, and I'm left with 78 equals 13x. Divide both sides by 13. I'm going to bring my answer up here. 78 divided by 13 is 6. Go back to the question. It's asking for the value of x, so I am done. I get 6. So a quick review of functions. So for a function, remember each x value, which we can also call the input, can only have one y value, which we can also call the output. So when I look at my yes example for a function, all of my x values, none of them repeat, they all have one single y value. 4 has a y value of -5, 2 has a y value of -3, and 5 has a y value of -1. That is a function. When I look at my table, the table is not a function because I see my x value of -1 repeats. And it has a different y value. The first -1 has a y value of +2, and the second -1 for x has a y value of -2. Those are not the same. It is not a function. That x value of -1 can only have one single y value. Different x values, though, can have the same y value. So when I look at the table, I see that I have two y values of +1, but my x values are different. That is okay, because when I look at my table, x of -1 doesn't repeat. X that is +1 doesn't repeat. So the x value of -1 only has one y value. It's +1. +1 for my x value only has one y value, +1. So as long as each x value only has one y value, then that's all that matters for functions. Our y values can repeat, that's okay. Our x values, is what cannot repeat. So for the graph of a function, we see some examples on the left. So anything that has a straight line that goes up or down like we've been used to is a function. Each x value only has one y. The one below it, right here, even though it's curvy, that's still a function. It's not a linear function, but it is a function. Remember, you can use your vertical line test to tell if it's a function. So what I mean by that is if I draw a vertical line at x equals -4, it hits the line one time. So that means that x value of -4 only has one y value on that line. Same thing here. My x value of +2 only has one y value on that line. Same thing here, here. So no matter where I draw that vertical line, if my x only has one y value, it only hits the line once, then it is a function, regardless of if it has curves or if it's straight. On the right examples are not a function. Still can use that vertical line test. If I draw a vertical line at -1, that x value has two y values. It hits the graph up here and it hits the graph down here. So therefore, that x value has two y values. It hits the line twice, so therefore it is not a function. Same thing with this vertical line. Any straight vertical line is not a function, because this is saying that x is only equal to -8. Always. It never strays from -8, which means it has all of these y values. Again, this line is +8. It has tons of y values, and remember, each x value can only have one y value. So any vertical line like this is not a function. So these key points are already in your notes. However, if you want it more recent, feel free to pause it and write this down. So a linear graph is a graph that has a straight line. So everything that we've been doing, for the most part thus far, something like this, that's a linear function. That is a linear function. A linear function also has a constant rate of change between each x and y point. In another word, constant rate of change is slope. So between every clear points, there's a slope, the same slope. It's a table or set of points where the change in y over x, again, that's also called slope, is the same between each set of points in simplest form. We cannot accurately compare them unless we put it in simplest form or divide it out. And then for an equation, there can be no exponents. That will not create a straight line. So how do we figure out if a set of points or a table creates a line if we don't want to graph it? Okay, quick review. Remember, if we have a set of points that's horizontal, the easiest way to see it is go ahead and put all of our points in a table. So go ahead and do this with me on your paper. So 4, 3. Always pause the video if you need more time. Okay, so if I were to plot these points to be a straight line, it would have to have the same slope between all of my points. So the slope for the first 2 points from 3 to 5 is an increase of 2. So my slope is up 2. And then from 4 to 1 is a decrease of 3, so negative 3. So my slope for the first 2 points is 2 over negative 3, or negative 2/3. I can't simplify. I could divide it out to get 0.6 repeating. Okay, next one, from 5 to 7 is also an increase of 2 over, from positive 1 to negative 2 is also a decrease of 3. So same slope, positive, or 2 over negative 3, or just negative 2/3. From 7 to 4 is an increase of 4. Now we can't automatically say, oh, that's not the same slope, because again, it has to be the same, and we have to compare in simplest form. Over the change in the x, from negative 2 to negative 8 is a decrease going further into our negatives of negative 6. Now when I write this slope out, 4 over negative 6 can be simplified. I can divide both the numerator and the denominator by 2, and when I do that, I get 2 over negative 3. So even though in the beginning it didn't look like it, I do have the same slope between all of my points that I'm given, so it is a linear function. If I plot these points, it will create a straight line. No bends, no curves. Okay, same exact thing for our table. That's already written vertically. Change in my y from negative 3 to 0 is an increase of 3. And I'm going to go ahead and write my slopes down here. 3 over from 1 to 2 is an increase of 1. 3 over 1. From 0 to 3 is also an increase of 3. So my change in y is 3 over my change in x from 2 to 3 is an increase of 1. So far, so good, same slope. From 3 to 7 is an increase of 4. Again, it's a different number, but like we learned from last time, we can't compare until it's absolutely simplified. And from 3 to 4 is an increase of 1. 4 over 1 is simplified enough as far as I can go. So I see here that these are not the same slopes. Yes, the first two have a slope of 3, but since the last set of points, there's an increase of 4 that time, it is non-linear. It is a function because each x value only has one y value, so it's a function. It's just not a linear function because my slopes are not all of the same. Again, you should have these in your notes. If you don't, take a moment and write these down for determining whether an equation is a linear function. So for a linear function as an equation, it's anything in the form y equals mx plus b, or an equation that could be rearranged to be in y equals mx plus b. So y equals mx just means that we don't see a plus or minus a number. It means that our y-intercept is 0. Y equals x, again, means I don't have my y-intercept is 0, and my slope would just be 1. X plus y equals whatever is over here, equals any sort of number is a linear function, because I could rearrange it so that x could be on the right side and I would be left with y equals. And then y equals any number. That is a linear function. Let's say y equals 7. That means I would go up to 7 on my y-axis, no slope, a slope of 0, so I wouldn't go up or down, so this would be my line. That's a straight line, and each x value only hits the line one time, so it's a function. For nonlinear functions, anytime we have an exponent with x, that's a nonlinear function. So x squared creates a graph like this, a u or an upside down u. Anytime we have a variable in the denominator like this, that is a nonlinear function. And then anytime our x and y are multiplied, when they're touching like that, that means multiplication, it's a nonlinear function. For not a function at all, it's when we have x equals any number. So we already saw that from before. A graph of x equals any number means, let's say for instance, x equals 2. I would go to 2 on my x-axis, plot a point. There's no plus or minus b, not moving, doesn't have a slope there. So x equals positive 2 means I'm not straying from 2. It is only x equals 2, which, like we said before, means that this line has tons of y values, an infinite amount. And our x value cannot have more than one y value to be a function. And then lastly, anytime our y has a square, y squared, no matter whatever it equals to, that is not a function. So if x has an exponent, it's a nonlinear function. If y has an exponent, it's not a function. Okay, you're going to determine, is the equation linear, nonlinear, or not a function? Think about A, write it down. A is linear. No exponents, no variables in the denominator, x and y aren't multiplied. It's in the form y equals mx. So my slope is up 4/3 minus b. My y-intercept is 2/3. It can be a fraction, it can be a decimal. B, think about it, write it down. B is a non-linear function. I've got a variable in the denominator. C. C is a linear function. Y equals -8. Anytime y equals one number, it is a linear function. D, non-linear. I've got an exponent with my x. Doesn't matter what the exponent number is, nonlinear. E. E is not a function at all. X can only be 4, which means it's got lots of y values on that line. And then F is a linear function. No exponents. My x and y are not multiplied, they're added, so that's fine. It's a linear function. All right, which ordered pair, if we add it to the set below, so if we put it in place of this x and y, will prevent the set from being a function? Take a minute, think on your own. Okay, the answer is going to be D. So if we are preventing it from being a function, that means we're going to add in a point that has the same x value as it already is. So if I look at A, just go through your choices. If I choose A has a slope, or not a slope, A has an x value of 5. I don't see any x values of 5. So if I put 5, -1 in here, that would still be a function. I wouldn't have an x value that repeats. B, 1, positive 5. I look at the x values I don't have any 1s, so if I put in 1, 5, none of my x values would repeat, so it would still be a function. C, 0, 0. I don't have any x values of 0, so I could put 0, 0 in for x, y, and it would still be a function. I wouldn't have any repeating x's. So D, I have an x value of 4. I see right here that I have a point that already has 4 as an x value. So if I plug in 4, 7 in for this x, this is going to make it not a function because 4 right here has a y value of -1, and then it's saying it would have a y value of 7 in the next point, and again my x value can only have one specific y value. So D is our answer because if I put that in, it prevents it from still being a function. Okay, go through and figure out which table is y a linear function of x. So easiest way is put these in a table to better able to see the change in y, change in x. Again, if it's linear, it has the same slope between all the points. 0 to -5, so I just have to test my points out, is a decrease of 5. Over from 0 to 1 is an increase of 1. Next slope from -5 to -6 is a decrease of 1. From 1 to 4 is an increase of 3, so my slope is -1 over 3. Those aren't the same slope. I don't need to keep going. I already know it's not the same slope, which means it's not linear. Okay, testing out B. From 0 to 7 is an increase of 7. So my change in y is 7 over my change in x. 0 to 1 is 1. 7 over 1 is 7. Next point, from 7 to 12 is an increase of 5. 1 to 2 is an increase of 1. 5 over 1 is 5. 7 over 1 is 7. Not the same slope. Can't be correct. Not be a linear equation. So obviously that would have to mean C is our correct answer, but let's just double check and see why. So change my slope for the first 2 points, plus 2. -1 to 0 is an increase of 1, so that's 2 over 1, which equals 2. 8 to 10, increase of 2. 0 to 1, increase of 1, 2 over 1 is 2. 10 to 12, increase of 2 for my y. 1 to 2, increase of 1, 2 over 1 is 2. And then lastly, 12 to 14, also an increase of 2. 2 to 3 is an increase of 1, so 2 over 1 is 2. So this is why it's linear, because all the slopes, all the rate of change between each point is 2, so it will create a straight line.